Here is 1991 AP Physics B exam question that I wanted to look with you at, and I see this a lot used in AP Physics questions where they give you the graph and you have to take the information from the graph and understand how to use the slope of the graph. So the question states that a battery with EMF, and they have a sign for the EMF, and internal resistance R is connected to a variable resistance R, and sometimes they call it potentiometer. So the capital R resistor is a potentiometer at points X and Y, as shown above in the on the left. Varying the potentiometer or resistor changes both the current and the terminal voltage Vxy. So the voltage between points X and Y is called the terminal voltage, and the battery, here is your battery, has some internal resistance. And this is, let me redraw it differently, so the way we used to look at the battery, so it looks like this. So you have the positive side of the battery and the negative side of the battery. Then they say that the quantities I and Vxy, the current and the terminal voltage, are measured for several values of different R resistances. And the data are plotted in the graph as shown above on the right. So we have to determine what is the EMF of the battery. We have to determine the internal resistance of the battery and determine the value of the resistance R that will produce the current of 3 amps. And then we will determine the maximum current that the battery can produce. So we need the maximum current. And the current and the voltage measured where measurements were made with an ammeter and voltmeter on the diagram. And so they show you what the ammeter and voltmeter will look like. Okay, let's look at the first ones before we jump to the last ones. So we need to determine EMF of the battery first for A. So I'm gonna start writing the equation for Ohm's law. So your total voltage, EMF, minus the voltage dropped on the first resistor on the potentiometer, so it's the current through the circuit and the resistance of the potentiometer, and minus the current dropped on the internal resistance. I'm gonna call it R, little r, or lowercase r. So all of the voltage has to be equal to 0. Also, I see that this part is Vxy. So that's the voltage. The voltage between these 2 points is equal to I times R. So I can write that one as V times XY, or sub XY. So I'm going to rewrite this equation as EMF minus V times Vxy and minus IR is equal to 0. Then I'm gonna solve for, this is my y-axis. So this is my y-axis. And I'm gonna solve for the y-axis. So my y-axis is Vxy. So I'm gonna rewrite as Vxy is equal to negative internal resistance, the current, and plus the EMF. What I got here is this. It is the formula that you use in algebra. Y is equal to mx plus b. And this is very, very common on AP exam. So I cannot prepare you in the classroom for every single problem like this that you will see on AP exam, but you have to understand that these tricks come on AP exam very often. So you have to solve for, looking at your graph, you solve for y. So your y is Vxy. Your slope is the internal resistance, Your slope is the internal resistance. In our case, it's a negative slope, so I just can put plus negative there. But the slope is the internal resistance. And the y-intercept is your EMF. So if I prolong my graph, my y-intercept is going to be 4.5. So my EMF from here is 4.5 volts. And from the slope, I also can see that the slope is equal to, you have the rise over the run. Your rise is 0.5. And your run is 1. So internal resistance is 0.5 ohm. So we solve for A and B. In A, they ask you the EMF of the battery, so we found that is 4.5. And then for B, they ask you the internal resistance of the battery, which is found that one is 0.5. And then the next one, they say determine the value of the resistance that will produce the current I, 3 amps. So let's look at this graph again right here. And here is 3 amps. And it gives me VXY 3 as well. So from this part, I know that VXY is equal to I times R. VXY is 3, current DC is 3 from the graph, and times R, so R is equal to 1 ohm. So when they ask you determine the value of the resistance R that will produce the current I of 3 amps, so the potentiometer or the variable resistor will have to be set at 1 ohm, and that will produce 3 amps current through the circuit. And then for the D part, determine the maximum current that the battery can produce. So you can produce the maximum current when your potentiometer is set to 0. So if your potentiometer resistance is equal to 0 ohm, then you only have internal resistance left. So if the only internal resistance is left, you can rewrite this equation as EMF minus I times the internal resistance is equal to 0. Then you have 4.5 minus I times 0.5 is equal to 0. So the maximum current you can have is 9 amps. And the last part, they say the current and voltage measured were made with an ammeter and voltmeter. On the diagram below, show proper circuit for performing these measurements. Use ammeter to represent the ammeter and voltmeter to represent the voltmeter. So if I want to plug in my ammeter, it has to be plugged in into the circuit. So that means I have to plug in where the current will flow through it. So here is your ammeter. And if you want to show voltmeter or voltage, that will measure the voltage between points X and Y. So if you want to measure the voltage between points X and Y, you have to plug it in anywhere between 2 lines. So I'm gonna plug it in right here. So you don't have to disconnect the circuit. You just plug in into these 2 points. And the resistance of the ammeter, so the resistance of the ammeter is going to be equal to 0, because you don't want the current that is flowing. The current is always flowing from the positive to the negative. So you don't want the current to go through the ammeter and drop some voltage. So if the ammeter has some resistance, then the voltage is going to be dropped, and that affects the whole circuit. So we don't want any of the voltage be dropped, or the potential difference be dropped on the ammeter. But the potential difference, or the resistance between for voltmeter, must be equal to infinity or approaching infinity, so the resistance of the voltmeter must be approaching infinity, because you don't want any of the current that is going this way to actually take a different route and go through the voltmeter. So you don't want that to happen. So the voltage of the voltmeter is always set to approaching infinity, so the current never flows through the voltage or voltmeter. And then the current always flows through ammeter, but its resistance has to be 0, so no voltage is dropped on the ammeter. And all you have to do is to know how to plug in voltmeter and ammeter. So ammeter always has to be plugging into the circuit. So if you see the line, so you have to disconnect the line somewhere, plug in the circuit. So you see I disconnect right here, plug in ammeter, and then I continue my circuit. And then for voltmeter, it's always parallel to the, like, let's say if I want the resistance between these 2 points, the yellow ones, then I plug in my voltmeter parallel to that resistor where I want to measure the potential difference drop or the voltage drop. That is it for this question, and it applies to AP Physics 1 and AP Physics 2 material. So this question you might see on AP Physics 1 or AP Physics 2 material FRQ questions, and it used to be an AP Physics B FRQ question, so 1991, and I believe it's question 4. And thank you for watching, and I'll see you in the next video.